Hey Algebra 1, and thanks for tuning in. Today we're looking at Lesson 9.1, Part 1, and we're just going to talk about how to simplify radicals. We have 10 things to write in our notes today, so let's go ahead and get started. The first thing we want to know is the product property of square roots, and that is essentially when you're trying to multiply, when you have two square roots being multiplied, you can break them apart like this. We have 9 times 5 and under the square root radical sign, or the square root of 9 times 5. And your main goal is to set them apart individually so that one of them can be found using the square root. So, for instance, this started out to be the square root of 45. And so I just think about the factors of 45 that also have a perfect square. I have the square root of 9 times the square root of 5. That would give us the square root of 45. That can easily be solved by finding the square root of 9, which is 3, and then the square root of 5 is not a perfect square, so you just leave the 5 alone, and that would be how you get your answer. So what we're going to do is go ahead and write down what we see on this page, specifically maybe this example right here, so you know how it's done, and then once you're done, click play, so we can try some questions. Okay, so here's just another example here. You're going to factor using the greatest perfect square. So the greatest perfect square that can go into 108 is 36. 36 times 3 does give us 108, so that's why I'm breaking up 108 individually to be 36 times 3. And then I can find the square root of 36, which is 6. And then the square root of 3 is not a perfect square, so I just leave that alone. Okay, that would be all we're going to be working on today. So let's go ahead and give these a try. We have numbers 2 through 5 right here. Again, you want to try to break them up to be perfect squares, and then go ahead and simplify as low as you can. So let's go ahead and pause here, try it, and then once you're done, click play. Alright, so for number 2, I broke up 24 with a square root of 4 and a square root of 6. And the square root of 4 is 2. There's no square root of 6, so I would leave that one alone. So my answer for number 2 would be 2 times the square root of 6. For number 3, I have the negative square root of 80. This just means my answer is going to be negative at the end, so just to make sure you carry that with you. Factors of 80 with a perfect square, that'd be the square root of 16 times the square root of 5. And then the square root of 16 is 4, so I have negative 4 times the square root of 5. Number 4 is a little bit more difficult because you notice you have 49x to the third. You obviously can tell me the square root of 49, but maybe consider x to the third and how we can break that up. I'm going to go ahead and solve the square root of 49. That's going to be 7, so I'm going to put that down there. But x to the third can be broken up using a perfect square of x to the second times x. Okay, so we're doing the same thing here with the variable, except we don't have a number now. So x to the third is the same thing as x squared times x, and x squared we can find the perfect square of that, which is just x. And then we don't know what x is, so we're just going to leave that one in the radical. So my answer for number 4 is 7x times the square root of x. The last one for number 5, we're going to do it kind of the same way. 75 has the square root of 25 times the square root of 3, and then I'll just leave n to the 5 n to the fifth power on the outside for now. Square root of 25 is 5, and the square root of 3 we do not know. For n to the fifth power, we can actually break that down into the square root of maybe n to the fourth times the square root of n. Okay, and then the square root of n to the fourth would just be n to the second, and then the square root of n is unknown. So you could keep it like this, but we want to organize as best we can, meaning my radicals will go together like terms, and my two non-radicals will go together. So I'm going to bring the 5n squared together, and then I'm going to bring the square root of 3n together. So this should be what my final answer would look like correctly. Okay. The next thing we're going to talk about is the quotient property of square roots, and that it just means if we have a square root of a quotient, so a fraction essentially, that just means you can separate them to have their individual radicals. So like the square root of 3/4 can be the square root of 3 over the square root of 4, and then you would just solve from there. So again, let's take time now to pause so we can write down what's going on in number 6, and then once you're done, click play to see how it's done. So in this case, we're just going to use the quotient property of square roots. We have the square root of 15 is equal to the square root of 15 over 60, square root of 64, and then we just solve the square root of 64, which gives us 8. Okay, you can do the same thing whenever you have a variable. The square root of 81 over the square root of x squared, that's just going to give us 9 over x. Alrighty, so here are the last 4 in our notes we're going to try. We're just going to simplify the expression using the square root quotient property. So let's go ahead and pause here so you can try 7 through 10, and then once you're done, click play. So for number 7, I just separated my square roots to be the square root of 23 over the square root of 9, which means my answer is square root of 23 over 3. Number 18, notice I have my negative on the outside, so it just is going to go with me wherever these answers go. So the negative square root of 17 over square root of 100, and then the square root of 100 can be solved, so I have the negative square root of 17 over 10. For number 9, let's go ahead and separate those. Z to the second. The square root of 36 is 6. The square root of z is z, so I get 6 over z. And then number 10, when we separate those, we get 4x squared over 64. Okay. Then I would maybe consider separating the top one even further. So I would do maybe like this, the square root of 4 and the square root of x squared. Just to make sure that I get both of them, I went ahead and did the bottom because that was easy. Square root of 4 is 2, square root of x squared is x, all over 8. And then something we can do one more thing is we can simplify this 2 8s. 2 8s can be simplified to 1/4, so my answer was going to be x over 4. Okay, because I just simplified 2 8s to be 1/4 and kept the x. That is going to conclude our notes for today. Thanks so much for tuning in, and we'll catch you next time.